Nobody was supposed to find anything unusual that day. The cameras had been running for weeks, placed deep inside the Florida Everglades by researchers who expected to document the ordinary rhythms of a wetland still struggling under the weight of one of the worst biological invasions in American history. They had seen these recordings hundreds of times before. Sluggish water, sawgrass bending in the heat, the occasional flash of a wading bird or the slow passage of an alligator across the mud. What they did not expect was what the footage actually showed. What they did not expect was evidence that something had shifted. Quietly, without announcement, in the deepest and most inaccessible parts of a swamp that scientists have spent decades treating as a patient in permanent critical care. When the researchers hit play, the room went silent. And what followed changed the conversation about the Everglades in ways that nobody had fully prepared themselves for. To understand why this footage matters, you have to understand what the Florida Everglades actually is and what has been done to it. The Everglades is not simply a swamp, it is a living river. A slow-moving sheet of fresh water that flows from Lake Okeechobee southward across nearly 2 million acres of wetland, sawgrass prairie, mangrove coast, and cypress forest before spilling into Florida Bay. It is one of the most biologically complex and irreplaceable ecosystems on Earth. More than 350 species of birds live here or migrate through. 300 species of fish inhabit its waterways, 50 species of reptiles, 40 species of mammals, and 36 federally listed, threatened or endangered species, including the Florida panther, the American crocodile, and the West Indian manatee, depend on this landscape for their survival. The alligator, which most people think of as a symbol of menace, is actually an architect of life in this place. It digs the holes that hold water through drought. It creates the openings that fish and birds depend on when the dry season comes. Remove the alligator, and the whole system begins to unravel. This is an ecosystem where everything connects to everything else, and where the loss of any single piece carries consequences that ripple outward in ways that can take decades to fully understand. And yet, the Everglades has been under sustained assault for longer than most people realize. The drainage of its natural flow for agriculture and development throughout the 20th century stripped the wetland of its essential pulse of fresh water, leaving larger sections of it starved of the water it needs to function. Pollution from agricultural runoff altered the chemistry of the water itself, encouraging invasive plants that choke out the native vegetation. And then, beginning quietly in the 1980s and accelerating catastrophically through the 1990s and into the 2000s, came the invasion that no one fully anticipated until it was already too late to stop. Burmese pythons, massive constrictors native to the forests and grasslands of Southeast Asia, began appearing in Everglades National Park. They had arrived through the exotic pet trade, imported to the United States as novelty animals, and then released or escaped into a landscape that turned out to be, for them, a near-perfect environment, warm, wet, full of prey, and almost entirely inaccessible to the human beings who would eventually realize what was happening and try desperately to stop it. The scale of what the pythons did to the Everglades is one of the most staggering ecological stories of modern times. The footage coming out of the swamp in recent years has documented both the horror of that destruction and, now, the first fragile and astonishing signs of what comes after. A 2012 study that sent shockwaves through the conservation community found that raccoon populations in the southern Everglades had declined by 99.3%, compared to levels recorded before the pythons established themselves. Opossums had fallen by 98.9%, bobcats by 87.5%. Marsh rabbits, cottontail rabbits, and foxes had effectively disappeared from areas where pythons were most concentrated. In Everglades National Park specifically, wildlife officials have stated that pythons have eliminated 95% of the small mammals that once defined the biological activity of this landscape. 95%. That number sounds like an exaggeration until you walk into the swamp and experience the silence for yourself. The absence of rustling in the undergrowth, the absence of the small, quick movements that a healthy wetland produces, the eerie stillness of a place from which something fundamental has been removed. The python itself is almost impossible to find. This is part of what makes the crisis so maddening. A Burmese python can grow to 18 feet in length and weigh 200 pounds. It is the largest apex predator that the Everglades has ever hosted. And yet, it is nearly invisible to the people trying to find and remove it. The snake remains motionless for approximately 85% of its life, conserving energy between meals. Its scales mimic the color and texture of the sawgrass and water hyacinth and decomposing vegetation of the swamp floor with an effectiveness that borders on supernatural. You can stand 3 feet away from a python and not see it. You can sweep a flashlight across a canal bank and miss a 14-foot snake entirely because it has pressed itself flat against the mud and simply stopped being visible. Biologists who have spent careers in the Everglades describe searching for pythons as one of the most frustrating experiences in wildlife management. The knowledge that the enemy is everywhere, and the inability to find it with any reliability. Mike Kirkland, the lead invasive animal biologist for the South Florida Water Management District, put it plainly when asked about the challenge his teams face. He said that removing pythons is actually fairly simple once you have one in hand. The problem, he said, is detection, finding them. In an environment that covers thousands of square miles where the water is murky, where the vegetation is dense, and where the snake has evolved over millions of years to be invisible, is the thing that has defied every conventional strategy. Shooting incentives, cash prizes for the longest snakes caught, competitive removal events open to the public, all of it has put pressure on the python population at the margins. But none of it has come close to reaching the interior of the invasion, where the snakes breed and feed and spread without ever crossing a road or a levee where a human being might spot them. The footage that has changed the conversation began emerging more meaningfully when researchers in recent years dramatically expanded their use of trail cameras in remote areas of the swamp. The Florida Wildlife Conservation Commission, in a project called Everglades Wildlife Watch that launched in 2024, began placing cameras across a 1.6 million acre zone in South Florida, and invited over 16,000 volunteers to help classify the millions of images those cameras generated. That project has since expanded statewide, now covering 6 million acres under FWC custodianship. The sheer volume of visual data being gathered has given scientists their first genuinely comprehensive picture of what is happening inside the swamp in real time. And what that picture shows is not a simple story of unrelenting catastrophe. It is something more complicated and in some ways more hopeful and in other ways more alarming than the straightforward narrative of collapse that had dominated the discussion for years. What the footage has captured in locations where intensive python removal efforts have been concentrated and sustained is evidence of ecological stirring. Native animals, tentatively and inconsistently, beginning to reappear in zones from which they had vanished. A trail camera in Collier County recording a marsh rabbit moving through brush at the edge of a clearing, the first documented sighting in that specific area in years. Wading bird activity increasing in sections of the wetland where mammal populations had been most devastated, alligators returning to areas they had abandoned. These are not triumphant. Recoveries, they are tentative signals, partial and fragile and easily reversed. But they are signals that the researchers reviewing this footage did not confidently expect to see on the timescale at which they are appearing. The assumption had been that even if python removal efforts succeeded in reducing snake density significantly, the recovery of native prey populations would take a generation, 10, 20, perhaps 30 years. The footage suggests that in some locations, under the right conditions, the timeline may be shorter than that. The Conservancy of Southwest Florida broke its own record during the 2025 to 2026 breeding season, removing 177 Burmese pythons from a 200 square mile area in Collier County between November 2025 and April 2026. The combined weight of those snakes was 8,080 pounds, more than 4 tons of apex predator extracted from a single section of the ecosystem in a single season. The largest female captured weighed 153 pounds and stretched 17 feet long. The average female removed that season weighed 95 pounds and was carrying approximately 70 eggs, which means that in addition to 177 living adult snakes, researchers also removed 4,100 eggs from the system. The total biomass eliminated in this single season was the largest the Conservancy had achieved since launching its python program in 2013. And the method that made it possible, radio tagging male pythons and using them as living guides to locate females during the breeding season, is itself a kind of science fiction made real. Researchers call these tagged males scout snakes. One of them, scout snake number 118, nicknamed Snakwan, led researchers directly to a 17-foot, 148-pound female in the very first capture of the 2025 breeding season. But even as the Scout Snake program was producing its record-breaking numbers, scientists from the South Florida Water Management District and the University of Florida were deploying a technology that would have seemed absurd if it had been proposed 15 years ago. Solar-powered, remote-controlled robots designed to look, move, and smell like marsh rabbits, the very prey species that pythons have nearly driven to local extinction, were placed in camera, monitored enclosures across the swamp. 120 of these robotic rabbits, each one costing approximately $4,000, were deployed during the summer of 2025 as part of a pilot program designed to address the single greatest obstacle to python control, not removal, but detection. The devices are retrofitted from toy rabbit bodies and equipped with heat emitters to mimic body temperature, subtle mechanical movements to simulate breathing, and muscle twitches, and eventually synthetic scent technology modeled on real rabbit chemistry. When a python approaches, the camera system sends an alert to wildlife staff, who can then dispatch a removal contractor to the location. The initial trial phase, conducted before the robotic decoys were introduced, used live rabbits in protective cages. Over a 3-month period, that trial detected 26 pythons. Whether the robotic versions will improve on that number at scale is something researchers are still measuring, but what the program represents and what the footage from those camera enclosures is beginning to document is a fundamental shift in the way scientists are approaching the problem. For years, the Everglades python crisis was characterized by a sense of helplessness, a feeling among even the most dedicated researchers that the scale of the invasion had outpaced the available tools by so wide a margin that meaningful progress might simply be impossible. The robotic rabbit program, ridiculous as it sounds in summary, is evidence that this helplessness is giving way to something else: creativity, systematic experimentation, a willingness to try things that don't fit into conventional wildlife management frameworks, because the conventional frameworks have been proven insufficient. Not all of what the cameras are revealing is hopeful. The footage has also documented something that researchers describe as a deeply unwelcome surprise: the presence of spectacled caimans in sections of the Everglades that the ongoing restoration program has been actively working to rehabilitate. The spectacled caiman, a carnivorous reptile native to Central and South America, was introduced to Florida through the same pathway as the python, the exotic pet trade. When pet owners could no longer manage these animals as they grew, they released them into the wild. The Everglades restoration program, which has been underway for more than 2 decades, has created new ponds, canals, and marsh areas, specifically intended to provide habitat for native wildlife and support the recovery of the broader ecosystem. Those new water features, designed for Florida's native crocodiles and alligators, are now being colonized by spectacled caimans as well. More than 60 species of non-native reptiles and amphibians currently live in Florida. The caiman is among the most ecologically disruptive of them because it competes directly with the American alligator and the American crocodile, both keystone species whose ecological roles are essential to the functioning of the entire Everglades system, for the same food sources, the same nesting sites, and the same territorial space. The footage that has captured caiman activity in restored marsh areas has forced a difficult conversation among restoration ecologists. The work of rebuilding the Everglades, of restoring the natural freshwater flow, of removing invasive vegetation, of creating new habitat, is expensive, slow, and technically demanding. The comprehensive Everglades restoration plan represents one of the largest ecological restoration efforts ever undertaken, a project spanning billions of dollars and decades of implementation. If the habitat created by that restoration is being captured by a new invasive predator before native species can reestablish themselves, it represents a threat to the entire investment. The footage does not resolve this question, but it raises it in a way that field surveys conducted without cameras never quite could, because the cameras are recording what is happening when no human being is present. And what is happening when no human being is present turns out to be a great deal more complicated than any model had predicted. There is something else the footage has documented that sits outside the framework of both hope and alarm and belongs instead to the category of the simply extraordinary: alligators fighting pythons. Not the symbolic or hypothetical conflict between native, predator, and invasive species that scientists have long discussed, but actual encounters, recorded in the wild, in which Florida's most ancient and most powerful native reptile confronts the invader directly. The footage of a large alligator consuming a Burmese python in the Shark Valley section of Everglades National Park, captured by amateur wildlife photographer Allison Joslin and shared widely, became one of the most viewed pieces of Florida wildlife footage in years, precisely because of what it represented. Not just a dramatic interaction between two large reptiles, but a moment of ecological pushback. The alligator, which has no natural predators in the Everglades and which has been documented preying on pythons in multiple recorded instances, is the one native animal in the system that appears capable of turning the tables on the invader under the right circumstances. What researchers want to know, and what expanded camera networks are beginning to shed light on, is how frequently this happens, and what size, classes of python it is most likely to occur, and whether alligator predation pressure on pythons plays any meaningful role in regulating snake populations in areas where both are present. Since the year 2000, more than 23,000 wild Burmese pythons have been removed from Florida and reported to the Florida Wildlife Conservation Commission. Governor Ron DeSantis highlighted the record-setting removal numbers achieved by the state's Patrick program, the Python Action Team removing invasive constrictors, in 2025, calling for continued annual funding built on the state's initial $2 million investment. The numbers are large, and yet biologists estimate that between 100,000 and 300,000 Burmese pythons may currently inhabit the South Florida region. The Arithmetic of this is sobering. Every removal represents a genuine contribution to the effort. Every breeding female intercepted before she can lay her clutch of 50 to 100 eggs is a meaningful intervention. But the gap between the numbers being removed and the estimated population remaining is wide enough that the conversation among scientists has shifted from asking whether eradication is possible. The consensus is that it almost certainly is not, at least not with the tools currently available, to asking something more pragmatic and more difficult. Can we suppress the population enough in enough of the right locations to allow the native ecosystem to persist? Can we buy enough time, through enough innovation, to keep the Everglades alive while longer-term solutions are developed? The footage from the swamp cameras is the most honest answer available to that question right now, and the answer it gives is provisional and conditional and deeply uncertain, which is to say it is an honest scientific answer. In some zones, under intensive and sustained pressure, the ecosystem is showing signs of resilience that exceed what models predicted. In other zones, new invasive pressures are emerging to fill the space that python removal efforts are creating. The technology being deployed to address the crisis is evolving faster than at any previous point in the history of Florida wildlife management. And the public engagement with this story, the 16,000 volunteers classifying trail camera images, the competitors who show up to the annual Python Challenge, the millions of people who have watched footage of robot rabbits and scout snakes and alligators eating pythons, has created a level of awareness and investment in the fate of this ecosystem that did not exist 20 years ago. The Florida Everglades has been called a river of grass. It has been called the lungs of South Florida, the source of drinking water for millions of people, the last great subtropical wilderness in the continental United States. It has also been called, with increasing frequency in recent years, one of the most endangered ecosystems on Earth. All of those descriptions are accurate, and the new footage being recorded in its deepest and most remote corners, footage that scientists are reviewing with the combination of disciplined analysis and honest shock that characterizes good science encountering something it did not fully anticipate, is adding new chapters to its story that no one had written in advance. Some of those chapters are devastating. Some of them are quietly, cautiously encouraging in ways that the researchers describing them are careful not to overstate. All of them are real, and all of them are happening right now, in the murk and the heat and the vast green silence of a place that has survived ice ages and hurricanes and a century of human mismanagement. And that is still, against considerable odds, fighting to survive what we have done to it. The cameras are running. The footage is coming in. And what it reveals, for anyone willing to sit with the complexity of it, is not a simple story of disaster or of recovery. It is the story of an ecosystem at a turning point, pushed past every limit that anyone thought it could endure, and still, in places, pushing back. What makes this particular moment in Everglades history so striking, when you step back from the individual data points and try to read the whole picture at once, is the collision of timescales that is occurring simultaneously in this one place. The python invasion unfolded over roughly 30 years. Slow enough that its early stages went largely unnoticed, fast enough that by the time the scientific community had documented the full magnitude of what was happening, the damage was already staggering, and the window for early intervention had long since closed. The restoration of the Everglades' natural hydrology has been underway for over 20 years and will likely take another 20 or 30 years to complete. The recovery of mammal populations, even under optimistic projections that assume sustained removal pressure on pythons and no new invasive pressures emerging to complicate. The picture is measured in decades, and yet the footage being captured by the trail cameras placed throughout the system is documenting changes that are occurring on a scale of months and years. Subtle, flickering, uncertain changes, but changes nonetheless. This compression of timescales is one of the most important scientific observations to emerge from the footage. Ecologists have long treated ecosystem recovery as a slow, linear process. Remove the stressor, wait, observe gradual improvement. What the models predicted, that under the right conditions, ecological systems can respond faster than their own history of degradation would seem to allow. This does not mean the crisis is over or that the interventions are anywhere near sufficient. It means the ecosystem is more alive than its condition suggested, that it has reserves of resilience the damage had not fully consumed, and that this changes what is possible if the effort is sustained. The people doing this work are aware of how fragile that possibility is. The biologists who wade into the water at dawn, who carry out 130-pound pythons through miles of sawgrass, who review thousands of hours of trail camera footage looking for a flash of fur that might indicate an animal returning. These are people who are not given to unfounded optimism. When they describe what the footage is showing, they describe it carefully with the hedging and qualification that defines responsible science. But beneath the careful language, there is something else, a quality of alertness, a sense that the story they thought they were telling may have a dimension they had not fully accounted for. The Florida panther offers perhaps the most instructive parallel for what might be possible in the Everglades if the right conditions are met and the right commitments are sustained. In the early 1990s, fewer than 30 Florida panthers remained in the wild, a single, isolated population in the cypress swamps and hardwood hammocks of southwest Florida, so genetically depleted by inbreeding that the animals were developing physical abnormalities and producing fewer and fewer viable offspring. The species appeared to be weeks or months from functional extinction. What happened next was the result of a deliberate, controversial, and scientifically guided intervention. 8 female Texas pumas were introduced to the Florida panther population in 1995, introducing new genetic material and reversing the inbreeding spiral. Within a generation, panther populations began to recover. By February 2025, a trail, camera on private land in Florida, captured footage of a Florida panther in an area where the species had not been recorded in decades. The population today, while still endangered and still critically dependent on protected habitat, has grown to somewhere between 120 and 230 individuals. The panther's recovery is not a complete story. It is an ongoing struggle against habitat fragmentation, road collisions, and the relentless pressure of South Florida development. But it is proof of what becomes possible when the right intervention is made at the right moment with the right level of commitment, and when the cameras are running to document what follows. The trail camera images that volunteers and scientists are now processing through the Florida Wildlife Watch Project on the Zooniverse platform represent something genuinely new in the history of Everglades science. Previous monitoring relied on field surveys. Teams of biologists walking transects, setting traps, conducting point counts for birds and mammals in specific locations on specific dates. This kind of monitoring is rigorous and valuable, but it is also inherently limited by what humans can physically observe and how often they can be in a given location. The cameras have no shifts. They do not need to be flown in by helicopter or driven out on airboat before they can do their job. They record continuously, in the dark, in the rain, through the heat of summer and the relative cool of the dry season, capturing everything that passes within their field of view without fatigue or distraction or the inadvertent. Human tendency to see what you expect to see rather than what is actually there. The result is a data set of a scope and objectivity that field surveys cannot match, and the patterns emerging from that data set are challenging some of the assumptions that field survey data had seemed to confirm. Among the most significant of those challenges is the question of where exactly the boundary between devastation and recovery actually sits in the current Everglades. The conventional picture, built from decades of field surveys concentrated in accessible areas near roads and water control structures, suggested a fairly uniform pattern of mammal absence across the python's range. The camera data is beginning to complicate that picture. In some remote interior zones that field surveys could rarely reach, cameras are recording mammal activity at levels that were not expected, given the estimated python density in those areas. Whether this reflects natural variation in python distribution, local differences in habitat that favor prey survival, or something else entirely, is a question that researchers are actively investigating. But it is a question that the cameras raised, that field surveys, for practical reasons, could not. The Everglades will not be saved by cameras alone, or by robot rabbits, or by record-breaking python removal seasons. It will be saved, if it is saved, by sustained political will, consistent funding, scientific ingenuity, and long-term commitment. The restoration of the natural water flow requires the cooperation of agricultural interests, water authorities, federal agencies, and state governments across decades. The containment of the python population requires tools that do not yet fully exist, deployed at a scale not yet achieved. These are generational commitments, but the footage is real. The marsh rabbit captured on a trail camera in Collier County, moving through brush in a zone where rabbits had not been recorded in years, is real. The 4,100 python eggs, removed from the ecosystem in a single breeding season, eggs that will never hatch, snakes that will never hunt, damage that will never be done, is real. The robotic rabbit sitting in its camera-monitored enclosure in the Everglades, solar-powered and faintly absurd and representing the full creative desperation of a scientific community that refuses to accept defeat, is real. And the silence that fell over the room when researchers first played back the footage that showed something unexpected, something that defied the worst projections, something that suggested the Everglades might have more fight left in it than anyone had dared to assume, that silence was real too. It is the silence of scientists encountering evidence that their models were incomplete. It is the silence of people who have spent careers mourning something they believed was already lost, and who are not quite sure what to do with the possibility that they were wrong.